Hi everyone. Today in the series of theory of computation lectures, we'll see how to construct a finite automata for a given problem statement. Right. In the previous lecture, we have seen what is finite automata and what is the phi tuple notation of finite automata, and also we have seen how to represent that finite automata using transition diagram as well as transition table. And today we'll see how to construct that finite automata in the case of. So if they are giving some problem statement, they are asking to find the finite automata and how to approach those kind of problems. These kind of problems will be asked in the gate kind of lectures, even in TRB, all those things you can expect these kind of problems. Okay, so for solving that problem, you have some rules here. Actually we can make it as call it as a formula here. So we all know finite automata is a mathematical notation which consists of number of states, right? So if they are giving some problem statement, you have to identify, first of all you have to identify how many states needed for that particular automata. Okay, so for that we have three different formula here. Okay, three different formula. So whenever you just remind that you just remember that whenever you see w is the string length. Okay, so w is a string actually. Okay, but here when I say w is a string, okay, it means string. Okay, the input which you are going to give to the machine finite automata. So here when I say square inside the square bracket, when I write w, which means the length of that string, right? So whenever you find length of the string is equal to n, okay, then number of states required is n plus 2. You have to remember these formula. Okay, these formula, though these three formulas are here to construct the to find out the number of states, you have to apply your own logic also in some kind of situation. Okay, first of all you just have three formula. What these three formulas says: first formula says whenever a length of string w is equal to n, then the number of states required is n plus 2. Okay, n plus 2. Okay, just remember that the formula. And second category is whenever the length of the string w is greater than or equal to n, which means I have to take n plus 1 states. Okay, third one is number of length, that is length of the string is less than or equal to n, then number of states required are n plus 2 again. Okay, just remind, you have this format in your mind. So when they are asking some questions, just apply that, and I will also tell you how to fix that number of states. Okay, so first we will see the first diagram, first problem statement. They are asking to design a finite automata which accept only the input 101, only the input 101. Okay, over the input set sigma that has 0, 1. So you understand what is the problem statement is, right? So they are asking to write a design of finite automata for accepting that automata should accept the input, only the input 101 over the set input alphabet set 0, 1. Okay, so whenever you have a problem these kind of problems, whenever you have these kind of set, I mean they are asking to find out the finite automata or for one specific input. Okay, in that situation you just find out what is w here. What is w here? W is 101, right, over the input alphabet 0, 1. So now you just see the length of the w, length of the string, that is 3, right? Other than this input string, they are not asking for any other string to accept the finite automata. Okay, I hope you understand that concept. So just listen what I am saying. Design a finite automata which accepts only the input 101 over the input set sigma 0, 1. Okay, so you know what is w here, what is the length of the w here. Other than this w, other than this input 101, you are not having any other input, right? So in that situation you just make it as the number of states. You have to find out the number of states for this finite automata. First requirement is the number of states. So here you have 3, right? The length is 3, so which means you just make it as 3 plus 1. Okay, so which becomes 4, right? Which becomes 4. So you will have automatically, you just have 4 states here. So this is the skeleton we are drawing. So we have 4 states here. So one will be a starting state, one will be any one of these state will be a final state. Now you have to accept 1 0 1, right? So first you just understand the skeleton first. So when you are in state, the first state, you just name that also. Okay, I can name this as, you can name anything. Okay, I'm just naming A B C D. Okay, we'll have it. Okay, you can name this 0 S1 S2 like that. So now what is the length of the string on the state A? When you are in state A, what will be the length? Just to think it. Okay, what will be the length? You have seen you are in state A. What will be the length you might be seen in that particular A? Okay, length of the string at the state 1, that is A. Okay, you have not seen anything, right? So which means 0, right? You have not seen any string on the state A. Okay, this is the status, right? So which means the length of the string is 0 here. Okay, you would have not seen anything. But when you reach B, you would have seen 1, the string with length 1, right? So here the length is 1. Okay, if you are in state B, you would have seen the string with the length 1. Okay, here when you are in state C, what might be the length? You would have seen 2, right? The length of the string should be 2. You would have seen a string with the length 2. But when you are in D, you would have seen the string with length 3, right? I hope you understood this skeleton. Okay, so when you are in state A, you might have not met any string, which means you have not read any string. The length of the string is 0. But when you are in state B, you would have seen at least a string with length 1. Okay, not at least, you would have seen only a string with length 1. Okay, when you are in C, when you are in state C, you would have seen the string with length 2. When you are in D, you would have seen length with a string length with length of 3. Okay, now you just read 101. You have to, this machine should accept this 101, right? So when the machine sees 1, whether this string it has seen 1, right? Whether you have to accept that one? No, because after seeing 101 only I have to accept that. So I will just make a transition to A to B. I have 4 states. I'm just connecting these states. So I'm just having a transition from A to B with the input 1. The first input read by the machine is 1. The second input is 0. So again I'm in state B. I'm seeing the symbol 0. I have seen 1 already. Now I am just reading this symbol 0. So which means it should go to next state, but it is not a final state. Okay, after that I am having 1, right? So which means I can go to another state. Definitely this state will be a final state, right? So after seeing 101, that state should be a final state, right? So this is the diagram for this finite automata. Okay, this diagram is accepted. If you have given this diagram, you will get this is the answer for this is the solution for this diagram. Okay, so I hope you understood this first problem statement. We have to design a finite automata which accepts only the input 101 over the input set 0, 1. So first of all, you just see the length of the string which you are given and try to add 1 with that length, and you just find out the number of states, and I try to frame the finite automata. Okay, this is one kind. Okay, the second category is construct a DFA which accepts strings over sigma, that is A comma B, with the length at least 2. Just note down the term at least 2. How will you whenever you read a problem statement, try to come up with the language, right? I hope everyone know what is language. Language is the collection of strings, right? Set of strings, right? So what will be the member of the language? So they are asking to they are asking to design a DFA for strings with length at least 2 over the alphabets a comma b, right? At least 2 means what is the meaning? W is this string, just to take W is the string. At least 2 means what you, how will you write in mathematical notation? At least 2 means the string, the length of the string should be 2, or otherwise it can go more than 2, right? So which means greater than or equal to 2, right? But at least 2, greater than or equal to 2, this will be the mathematical notation for this such kind of problem. Length at least 2, so you have the formula for that, right? So W is greater than or equal to n, then the number of state required is n plus 1, right? So here 2 is here, to 2 plus 1 you will have 3 states, right? So you find out what is the 3 states, let it be. So but before that you just try to form the collection, right? So first of all you have to frame the at least 2 means the number of length should be 2, starting from length 2. So you have a comma b, right? First I will consider a, so which means I will have a as a member. A will be the member of the set language L, okay? And then I can have AB, right? Or otherwise I can have BA, or otherwise I can have BB. So in the length 2, at least 2, right? In the length 2 I have 4 members, right? After that I can have 3, the length 3, right? So I can make it as triple A, or otherwise I'm just a combination, making a combination ABA, ABB, or even BAB. Likewise the set goes on, which means at least 2 means more than it should, the length of the string should be 2, but it may exceed 2 also, right? It may have 3, it may have 4, it goes, you cannot limit that set, which means it is the infinite set, right? So let it be, this is the member of the language, okay? Member of the language L, okay? This is the problem statement given. So first of all you have find out what is the number of, how many number of states needed for this finite automata, that is deterministic finite automata. So now you have 3 states, right? So just to have 3 states, okay? You can also have, okay, 3 states you are having, just name that also, A, B, C, okay? 3 states you are having. First try to connect using the collection of the member, okay? You have, this is the set, right? This is the language, right? This is the problem statement defines. So first minimum length of the string, the length, minimum length of the string, right? What will be the minimum length? 2, right? So 2 means which, this is the one option, right? This is AA, so it should accept AA, right? When the finite automata looks for the string AA, it should accept that string, right? So which means the finite automata read A. So when I read A, it goes to one state, and upon after that I'm also having another A, so I'm just going to A, right? So when I see A, I should accept that, so which means this state should be a final state, right? I hope you have got the answer, half answer. Likewise you have to build up the finite automata. So now second input, just to have the second input, you have A, read, you have read A. So starting from A to the state, from A to B you have read A, and then you have B, right? So you can have either A or B. So when I read AB, I should accept, yes, this is accepted. Next to B, so now B, first it should read B, the symbol B, so I should have B, either A or B. So when I have B, I have to come to next state, and A, when I see A, I have to go to final state, and then also I have BB, that is also finished here. So these four are completed, okay? These 4 symbols, 4 strings will be accepted by this automata. But what about this AAA? So you try to come up. So you have AAA, right? First you just read the symbol A. So starting from A, the start state, you are giving the input A, and after seeing A, I am going to next state, and then A is there. So you are having A. You cannot go to what? You cannot go to final state, right? You cannot go to final state, right? So also we have already given input to state B, A, you have given symbol A on the state B, right? So now you are after seeing A, it goes to C, right? And also I'm having, but I have one more string to read, one more symbol to read, that is A. So A means I should accept that string. So I mean I have to make a self loop, right? So I will be having A here. So this string will be also accepted by this automata. And then A, B, A. What about A, B, A? We are giving A on the state A, capital A, it goes to B, capital B. And then on seeing B, it goes to capital C. And then on seeing A, it accepts the string. This is also accepted. And then this one, A, B, B. So when I give it sees A and goes to B, and B it goes to C, and also I'm having B here. So I will also have either A or B here, right? Okay. And then if I have 4 A's, what will happen? A, and then A. Likewise, you can have any number of combination. This automata will accept all the members of the language L, whichever we formed. I hope you understood how to frame this finite automata, deterministic finite automata. So just to see the length of the string. So and when you form the mathematical representation, whenever the length of the string is greater than or equal to 2, try to have a remind the states, number of states records is n plus 1. So I'm just confirming the number of states record, and then I'm just one by one I'm just making the skeleton of the finite automata, and then one by one I'm just having the example from the collection. One by one I'm just accepting that string. That's how I'm building that finite automata, right? So I hope you understand. After that, so you are not having any other. In this state, I want to mention you one thing, that you have 3 states, right? So whenever you are building a DFA, try to have in mind that a particular state, if you take any particular state on that given finite automata, you have to look for the symbols, input symbols. You have 2 symbols, right? The input set have A comma B, right? So you should confirm that, you should ensure that that particular state have the transition for both A and B. Okay, so when I see A on particular on the state A, capital A, it goes to B. When I give B on the state capital A, it goes to capital B, right? So this is over. There is no other transition possible here. Likewise, here also you have A, B. You have given A as well as B. Here also you have given A as well as B, which means there is no any other transition possible for this finite automata. This will be the final structure of the finite automata. I hope you are getting the concept, right? So if you have any doubts, you please mention in the comment box. Okay, this is the second category. Third one, construct a DFA which accepts the strings over A comma B with the length at most 2. Okay, at most 2. So previously we have seen at least 2. So now what does mean by at most 2? The length of the string will not exceed the number 2, right? And this is the mathematical notation, right? So when the length of this W is less than or equal to 2, right? It should not exceed the 2, number 2. At most 2 means that is the meaning, right? So when you have this format, this will be the third formula. This apply the third formula, and W, the length of the W is less than or equal to n, means that it has the number of states required is n plus 2, which means 2 plus 2, you will have 4 states here. Okay, you will have 4 states here. But before that, try to come up with the collection, right? Whenever you have a problem statement, try to come up the language, try to build the language, what all the members can be possible on the given problem statement. They are asking to form the at most 2, length with at most 2. So at most 2, in the sense, you have to understand the meaning. It may have 0 also, right? The length of the string may go to 0 also. That string also should accepted by the finite automata whichever you are designing. So which means first one is sigma. Sigma is that is null string, not sigma. Null string is the epsilon. Epsilon will be the member of the language L, and then I can have a symbol with the length 1, and that is A comma B, and then at most 2 I can have the string with length 2, right? So which means A B, B A, and then B B. After that I cannot have any other possibilities, right? This is the finite set. Please note that this is the infinite set, okay, but here you have L is the final state, finite set. It is the finite state. Now you have find out how many number of states required. Four states are required here, right? Four states are required here. So one will be the starting state, right? You can have, you just name it A B C D. Now you just first, the minimum possible length of the string is 0, right? 0 should be accepted by the finite automata, right? This is the problem constraint, right? So when I have not seen nothing, that I have not seen anything at that that state also, I should accept that, which means when I'm reading the empty string, I should accept that string also. So we are making it this A as the final state, and then when I see A, I should accept. When I see B at the starting, if I have B, I should accept. So which means this state will become final state. When I have 2, length 2, A, that case also I should accept. Okay, and then A, B, you will have either A or B. When I have A, where I have read A here, and then the first symbol is A and then B. So when I read the B, it goes to final state. B, A, again B, A, it accepts. B, B, what is B? B, B, accepted, right? Right? Only these are the members of the language, but you have one more state here. So which means that when I read symbol A on the C, way on the state C, capital C, I should not accept, which means my length of the string is exceeding the number 2, right? What the constraint says, it should at most 2, which means it should not exceed 2, right? So now when I say triple A, what will happen? A, it should not accept that. So when I have A, either A or B, I should not accept that, okay? So which means this will be the dead state, okay? So please note that this will be the dead state, okay? Dead state. Since they are asking to construct a DFA, what I should check? What I should check for? You have to check for each and every state whether I have a transition for every input in the input alphabet set. Yes, I have the transition for A, B. Here I have a transition for A, B. Here I have the transition for A, B. But here I have not given any transition. So which means I can make it as either A, B. So even if I receive A after this A, that will be in the dead state. Okay, this is the finite automata for the given problem statement. I hope you get the point which I am coming to say. The fourth problem is DFA over sigma with length exactly 2 exactly. Okay, this is the case for W is equal to 2. What will be the W is equal to 2? When I say W is equal to 2, what will be the number of states required? N plus 2, right? So N plus 2, which means 2 plus 2 you will get 4, right? So again you will have 4 states here. Okay, what will be the number here? What will be the member of the language here? Try to form a language here first of all. So you have A, B. So with length exactly 2, right? Exactly 2 means, you know, A, B, B, right? These are the members of the language. So now you just see A. This will be the starting state. This will be the starting state, and you don't know which will be the final state. So now you are having symbol A. You are going to next state. Okay, we are reading the symbol. You start from the minimum possible length. Here is 2 only. Exactly the length will be 2. So each and every string which are present here will be the length of 2. So you start from the number 1, first element of the set A. So I'm just having A and reading the symbol, next symbol A, and it comes here. So which means I should accept that, right? A. And then I'm having AB, I should accept. B, I should accept. B, I should accept. Okay. Since they are asking to draw the DFA, what will happen? So this state is remaining, right? You have D state, right? So which means when I get any other string after C, I should go to dead state, right? Either A or B, or even either A or B, I should go to dead state, right? Dead state, this will be a dead state, this one will be the final state. But when you compare this previous diagram, the same thing will be there, but the thing is 3 states will be final state, but here you will have only 1 state, right? The thing is, what is the difference you are finding here? This when you are being here, you might have seen nothing, right? So the length of the string is 0. Okay, but you are being on here, you might have seen at least one symbol, right? The length of the string is 1. What will be the length here? 2, right? At most 2. After 3 we are making it as dead state, but here same thing, 0 1 2. When I am seeing 2, I will make this status what? Final state, right? I hope you got some concept on this construction of DFA, that is Finite Automata. We'll discuss. If you have any doubt, please comment on the comment box, and we will clarify those doubts. In the upcoming lectures, we will see problems like this, and we'll also cover the syllabus. Okay, thank you.